Hi all, welcome back to Malware Analysis. I am J. Lavanya, Assistant Professor of CSE Department. Today in this video, we are going to discuss on the topic Unit 3, Reverse Engineering. Under that, we are going to see is that binary analysis tools. Let's dive into the topic. So, what is meant by binary analysis? It is the process of examining executable files or the binaries to understand their functionality, structure, and behavior without necessarily having access to the source code. Okay, and it also explores the different types of tools available and their functionalities and how they understand to foundation for the understanding of the tools and application in the field of cybersecurity and malware also. And what are the main binary analysis? So it is the process of examining the executable file, that is a binary, right? So it is crucial in various scenarios, like the first one in reverse engineering. So understanding how a software program works, often to identify some vulnerabilities, improve some interoperability, or create some compatible products. And second one, like malware analysis, dissecting malicious software to understand its capabilities, infection mechanisms, and potential impact. And third one, that is vulnerability research. So identifying some security flaws in software that can be exploited by some attackers. And fourth one, like software auditing. So ensuring that the software adheres to some security standards and its best practices. So these binary analysis tools are essential for performing these tasks effectively and efficiently. Okay, so they automate many of the tedious and complex processes which is involved in understanding the binary code. Okay, so this is the brief introduction of binary analysis. The next continuation is that types of binary analysis tool. So the first one, that is static analysis tool. Second one, dynamic analysis tools. Third one, combining static and dynamic analysis. So first of all, static analysis tool. So it involves examining the binary code without executing it. So this approach allows analysts to gain some insight into the program structure, control flow, and potential vulnerabilities without the risk associated with running potentially malicious code. Okay, and what are the key static analysis tools and techniques if you take? First one, disassembler. So these tools convert the mission code into some assembly language, making it more human readable. And popular disassemblers include IDA Pro, Ghidra, Radred2, and Binary Ninja. So first one, that is IDA Pro. It is a powerful commercial disassembler with some advanced features for code analysis and debugging. And second one, like Ghidra, a free and open source reverse engineering tool which suits and developed by the National Security Agency, and it offers disassembling, decompilation, and analysis capabilities. And next one, Radar 2, a free and open source reverse engineering framework with a command line interface. It supports a wide range of architecture and file formats. And next one, that is Binary Ninja, a commercial disassembler and a reverse engineering platform known for its user-friendly interface and powerful analysis features. And next one, like decompilers. So decompilers attempts to convert the assembly code back into the higher level language such as C or C++. So this can significantly simplify the analysis process. Example include IDA Pro's decompiler, IDA Pro that includes a powerful decompiler that supports multiple architecture, and second one, that is Ghidra's decompiler. Ghidra also has a built-in decompiler that can generate C code from the assembly. And next one, Red Tech, a free and open source retranslatable decompiler, and second one that is string analysis tools. So these tools extract the strings from the binary, which can provide clues about the program's functionality, configuration, or potential malicious activity. And common tools include like strings, that is Unix or Linux, a simple command line tool that extracts some printable strings from a file, and FLOSS, that is File I Labs obfuscated string solver. So that we used to call as a FLOSS, and a tool that is specifically designed to extract some obfuscated strings from the malware. And next one, that is PE analyzer, that is portable executable analyzer. So these tools parse the PE header of the Windows executables to extract the information about the program structure, dependencies, and resources. So examples include the PEID, that is a tool for identifying some packers and cryptos and compilers, which is used to create a PE files. And next one, CFF Explorer, a comprehensive PE editor and analyzer. And next one, Yara, that is rule scanner. So Yara is a pattern matching tool that allows analysts to create the rules to identify the malware families or some specific characteristics in some binary files. And next one, there is advantages of this static analysis tools. It is safe. It does not require some executing the code or reducing the risk of infection. And second one, there is comprehensive, so which can analyze the entire code base, including some rarely executable branches, and it is fast. It is generally faster than the dynamic analysis. And what are the disadvantages of static analysis? If you mean, it is limited by the obfuscation. That is, it can be hindered by the code obfuscation techniques and false positives. And it may produce false positives due to incomplete or inaccurate analysis. And it cannot analyze runtime behavior, and which does not reveal how the program behaves during the execution. And next one, like dynamic analysis tools. Yeah, first we have discussed about static, and next one we are going to discuss is about the dynamic analysis tool. So here, this dynamic analysis involves executing the binary in a controlled environment and absorbing its behavior. So this approach provides insights into the program's runtime activity, such as network communication, file system access, and registry modification. And next one, that is key dynamic analysis tools and techniques. What are the techniques and tools which is used? So first one, debugger. Debugger allows analysts to step through the code, examine the memory, and set the breakpoints to understand the program's execution flow. And popular debuggers include OLEDBG, a popular debugger for Windows executables known for its user-friendly interface. And next one, there is X64DBG, that is an open source debugger, right, for Windows executables supporting both x86 and x64 architectures. And next one, GDP, that is GNU debugger, that is a powerful debugger for Linux and other Unix-like systems. Okay, and next one, like it's a sandbox. The sandboxes provide some isolated environment for executing potentially malicious code. So they monitor the program's behavior and record its actions. So examples include Cuckoo Sandbox, like any open source, right? So any open source automated malware analysis system, and any run an interactive online sandbox that is used for analyzing the malware. And next one, that is network analyzer. So these tools capture and analyze the network traffic generated by the program, revealing its communication patterns and potential command and control service. And common tools include Wireshark, a widely used network protocol analyzer. Next one, TCP dump, that is a command line packet analyzer. And next one, that is system call monitor. So here These tools track the system calls made by the programs that provide some insights, into its interaction with the operating system. And examples include sysmon, that is system monitor, and procmon is the process monitor, right? And similar to that, the system call monitor we call a sysmon. And then a system monitor, a Windows system service that logs the system activity to the Windows event log. And next one, trace, that is Linux, a command line utility that traces the system calls and signals. And next one, memory dump analysis tools. So these tools analyze a memory dump to identify the sensitive information such as passwords, encryption keys, or injected code. And what are the advantages of using this dynamic analysis? So first one, reveals some runtime behavior. So provides insights into how the program behaves during the execution. And next one, bypasses the obfuscation, which can bypass some obfuscation techniques by absorbing the program's actual behavior. And next one, that is identifies the hidden functionality, which can uncover some hidden or undocumented features. Okay. And what are the drawbacks of this dynamic analysis? If you take risk of infection, that it requires executing the code, right? And which can be risky if the program is malicious. And next one, it is time consuming, which can be more time consuming than the static analysis. And environment dependent, the program's behavior may vary depending on the environment in which it is executed. Okay. And next one, anti-analysis technique. So malware may employ some anti-analysis techniques to detect and evade the dynamic analysis environments. Okay. The third one is that combining static and dynamic analysis. So combining static and analysis is the effective approach in binary analysis because it often involves combining static and dynamic analysis. And static analysis can provide an initial overview of the program structure and potential vulnerabilities, while dynamic analysis can reveal its runtime behavior and confirm or refute the findings of static analysis. And next one, that is static analysis tools. Okay, so next is that static analysis tools. So it involves examining the binary code without executing it. So this approach is useful for identifying some potential vulnerabilities and malware characteristics before the code runs. Okay, can you able to understand? So this is about the common static and binary analysis tools. So this is the comparison of how this static and dynamic analysis tools will be working, right? So in static analysis tools, as we have discussed already, right? So it has some non-execution of analysis and it has a potential vulnerability detection. And here also, if you take dynamic, it's a runtime behavior observation and real-time issue detection will be occurring in case of dynamic analysis tools. And why this, why we are going for these static and dynamic analysis tools in case of binary analysis means uh, mainly, binary analysis helps to identify the malicious code, even if it is obfuscated or packed. Okay. And next one, like vulnerability assessment, it helps to uncover the vulnerabilities in the software, both in custom code and third-party libraries. Okay. And next one, like reverse engineering, it allows for the understanding of how the software works, which is crucial for security audits as well as for research. And this binary analysis can be used to assess the security posture of software without access to the source code. And next one we are going to discuss is about challenges in binary analysis. First one, complexity. So reverse engineering can be challenging, especially with some obfuscated or packed malware. And next one, like reconstruction, restoring high-level code structures from disassembled code can be difficult. And third one, time consuming. analyzing complex binaries can be time intensive. And third one, like evolving threats, malware developers constantly create some new techniques to evade the analysis, which requires some continuous adaptation of analysis methods. Okay, so these are the comparison of static and dynamic analysis tools. Okay, so next topic is that we are going to discuss about what are the static analysis tools which we know. Okay, a static analysis tool which involves examining the binary code without executing. So this approach is useful for identifying potential vulnerabilities and malware characteristics before the code runs. So first one, IDA Pro or Gidra. So this is a powerful disassembler and decompiler that allow for in-depth analysis of binary code, revealing its structure and functionality. Second one, Binary Ninja. So a reverse engineering platform with disassembler and decompiler capabilities, offering a free version for the basic analysis, right? And third one, a Radari or Cutter. Okay, so this is a versatile reverse engineering framework, the command line interface that is Radar 2 and a graphical interface that is Cutter for examining and analyzing the binaries. Okay, and fourth one, that is PID or PE Studio. So this is a tool for analyzing the portable executable files commonly used in Windows to identify the packers, compilers, and other characters. Okay, and next one is the Yara, a pattern matching tool for identifying and classifying the malware samples based on some specific characteristics, and dependency worker, which helps to analyze the dependencies of a binary, revealing some external libraries and components it relies on. Okay, and there are so many static analysis which you know. So these are the common things. But apart from that, you have some dependency worker or EF is a library for analyzing some executable file, and Bing scheme that is analyzing P and ELF binaries, and CW checker, this is identifying some common weakness pattern in the binary. So these all comes under the static analysis tools, right? And next we are going to discuss is about dynamic analysis tools. So this approach is also involves executing the binary in a controlled environment. So that is we used to call some sandbox, right? And that observes its behavior and interactions with the system. Okay. So first one, Cuckoo Sandbox. So it is a popular automated malware analysis system that detonates malware samples in isolated virtual machines and monitors their actions. In second one, that is the Process Hacker. So it provides a detailed information about the running processes, including the loaded modules, network connections, and more. And next one, like X64DBG, or is called as Immunity Debugger. So debugger that allows for stepping through the code, inspecting memory, and analysis the runtime behavior of malware. Next one, Wireshark. So this is also a dynamic analysis tool, and it's a network protocol analyzer that can capture and analyze the network traffic which is generated by the malware. And these are the common dynamic tools. But apart from this, we have like Fiddler, Paradox, or Manticore. So Fiddler, it is a web debugging proxy that can capture and analyze some HTTPS traffic. It is useful for understanding the malware's network communication. And Paradox, so this is a Python-based reverse engineering sandbox that allows for scripting and automating some dynamic analysis tasks. And third one, like Manticore, symbolic execution and dynamic analysis tools that can explore some different execution paths of a binary according to some Linux circuit expert, they were saying, right? So these all comes under the dynamic analysis tools. Okay. So particular video, we have discussed about the binary analysis tools which are indispensable for reverse engineering and malware analysis. So, by understanding the different types of tools available and their respective strengths and weaknesses, analysts can effectively dissect and understand the behavior of software, identifying some vulnerabilities, and combat malicious threats. Okay. The continuous evaluation of malware necessity, the ongoing development and refinement of binary analysis tools and techniques. So in this video, we have discussed on topic called binary analysis and what is its definition and what are the types of binary analysis tools. We have discussed on static and dynamic and both static and dynamic analysis tools, and what are the limitations and what are the advantages, right? And apart from that, we have discussed what are the static analysis tools and what are the dynamic analysis tools which is used in binary analysis. And I hope this video will be very useful. We will see you in the next video. Thank you all.